Okay, and we're back for our next speaker. Our next speaker is Mark Prutsalis, who's the president and CEO of Sahana Software Foundation. Mark?
Great, thanks, Frank. Thanks for the introduction. So I'm here to talk to you today about how our experience supporting relief efforts for the Haiti earthquake of 1 year ago. And the Haiti earthquake brought, I think, almost a worst-case scenario for international disaster response organizations. It was a large earthquake that happened in a geographically isolated location that had a large and impoverished population with limited logistical capabilities for supporting relief workers, both in terms of food, shelter, transportation, and security. And so this scenario, I think, provided an opportunity for significant contributions from volunteers who were offshore to contribute meaningfully, perhaps for the first time in a large disaster like this. And our organization was a part of that, as were several others that I'm going to speak about today. Before we get to the case study specifically of how open source technology projects assisted in the Haiti earthquake relief efforts, I wanted to review quickly some material that's probably very familiar to our audience about disaster management, but particularly from the perspective of where technology solutions and information management can help, solutions like Sahana Software. And I'm going to give you some background on the Sahana Software Foundation and our history and work and history developing disaster management systems, so you'll have a better understanding of how these types of systems were applied to the Haiti response and how they might be useful to disaster management agencies in general. To begin, what is a disaster? Very simply, beginning with a simple but important definition that the UN uses, which emphasizes that a disaster is an event that exceeds the ability of the affected society to cope using its own resources. A more specific definition comes from the UK Home Office and sort of extends that to the thought that a disaster's effects are of the scale that cannot be dealt with by traditional emergency services and the local authorities and other organizations. So this makes disaster management, from my perspective, a little distinct from traditional emergency management tasks that don't require outside or ordinary assistance. And that's really the landscape where we come from. This is this is not rendered too well on here, but the typical cycle of emergency management from disaster, from mitigation, preparedness, response, and recovery. So when a disaster occurs, that disrupts that cycle, and we have to deal with the immediate aftermath. So what I wanted to do was sort of break down, apologies, the graphics didn't show up quite perfectly, but that response phase to a large natural disaster like the Haiti earthquake really combines two distinct sets of activities. There is the immediate life-saving tasks that need to be undertaken to rescue survivors with urban search and rescue teams, for example, firefighting, emergency medical care to save lives. And there's also the beginning of the relief operation in order to sustain the survivors and make sure that they continue to survive and are cared for. So activities such as providing temporary shelter and emergency food programs, distribution of water, sanitation facilities, as well as dealing with missing persons and providing ongoing health and medical care. So this is the space in which disaster information management systems like Sahana Software typically contribute in the relief phase. And that was very much the case in Haiti as well. Though there are some examples, which I'll talk about, where life-saving activities and search and rescue operations were facilitated by some of the things that were going on in this area. And I also want to point out that these phases do overlap quite a bit, and we saw that in Haiti, where search and rescue operations went on for 2 to 3 weeks, which is very atypical of a lot of earthquake responses. As a server relief worker, I'm used to arriving on the scene of a disaster 3 to 5 days after an event, and usually that's the the point at which the urban search and rescue teams are packing up and going home, and then you're going in and looking at, so I said, the temporary shelter and care and logistics that's needs to sustain the relief operation. In Haiti, these activities were very much overlapping for a long period of time, and that provided a bit of distinct challenges. Also, its background. So, disaster response activities come from three different groups of organizations. There is the official government relief that is in the tens of organizations, as shown on the slide. That's sort of recognized by everyone as the responsible and authorized authorities that are responsible for responding to disaster and taking care of the community. And then in a large-scale disaster, as I said, that branches out into hundreds of organizations, whether it's the UN agencies and charities such as the Red Cross, who have expertise and training to focus on care of people in large populations. But there's also a third group, which is really the disaster victims themselves and the communities and the people who are affected, corporations and the private sector, who are often the first on the scene, have a lot of capacity, and provide the volunteer resources that groups like the UN end up using to help manage the relief operation. And so the effective collaboration and coordination between all of these groups is really what's critical to providing relief for the victims. And this is an area where technology solutions, I think in particular, have great value. So in the aftermath of disasters, I categorize two separate areas where challenges in responding to the relief. There's the trauma cause and that affects both the victims of disasters as well as those responding, as well as the task of coordinating, managing, and tracking large numbers of people, places, and things that are important for the relief operation. And the bigger the disaster, the bigger the challenge this is. Again, these are some of the tasks facing responders during the response phase, includes many of these activities here. Life-saving decisions need to be made fast, and the best decisions are going to be the ones that are the most informed. So this is the area where technology can particularly help. Technology provides solutions that are scalable to handle the problems of disasters, that are efficient means of distributing information to those who need it, and provide a way of sort of aggregating information and data from multiple sources automatically to providing live updates and situational awareness to the people who are making decisions. So that's the basic background of sort of our perspective of technology. So the other thing I wanted to add to this was for a disaster and working with sort of the definition of the disaster as something that's exceeded local capability. That forces the response of a disaster to extend out to groups that the local authorities may not be used to working with, whether it's NGOs or the civil society, foreign aid, UN agencies, and consulting that wider group. All of a sudden, information is being gathered from non-traditional or uninitiated sources, and that is then a part of sort of the trend towards increasing the use of crowdsourcing and social media for providing better situational awareness about disasters and decision making. So, all that by way of background, I want to talk a little bit about the Sahana Software Foundation before going into the Haiti earthquake issues in some detail. The Sahana Software Foundation really serves this purpose. It provides systems that allow disaster response organizations to effectively collaborate and share information with each other, and to leverage non-traditional information sources by providing tools that address a number of the tasks that face responders, from reuniting families and tracking missing persons, understanding where shelters are, managing and tracking aid requests, And all of that serves to provide some transparency to the response effort, which is very important to any organization engaged in humanitarian assistance. The Savannah Software Foundation is a nonprofit organization whose mission is to help alleviate human suffering by supporting the needs of emergency managers, disaster response professionals, and communities themselves to have access to the information needed to better prepare for and respond to disasters. And we do that through the development of free and open source software and the promotion of the use of open data standards. Our projects are free and open source. There are no licensing fees to our software, and the source code is distributed. And this allows users who adopt Savannah software to make changes that are necessary for it to fit their needs and redistribute it in perpetuity without any barriers to that. It does not mean that it's without cost. There are costs certainly in terms of development and support, but there's no a price per se for the software itself. Another thing that Savannah software has always been designed to do is to be what on this slide is called portable. And what that means is that it can be used offline. It can be installed on a laptop or a mobile device, because we recognize that after a disaster, access to the internet may not be available, and very likely is not. So we need a system for allowing people to collect information and use our information offline, and then when the networks are available, to be able to send and share that with others. They're also modular in the sense that there are many different parts of the system designed to address common disaster management problems, and you only need to use what's relevant to your own organization. And finally, it's designed to be rapidly modified to meet the needs of any new requirement that comes up, and that's really at the heart of having an open source solution as well. The historic trigger for Savannah software was the 2004 Indian Ocean earthquake and tsunami, which affected several countries in the region, but particularly Savannah came out of Sri Lanka's experience, where it was first developed there in the weeks after the tsunami in Sri Lanka by the IT community, who wanted to do something to help their own country recover. And the software was used by their Center for National Operations to do things like tracking organizations who were working in the country, understanding where all the temporary shelters were, and providing a missing persons registry, as well as being used to track aid requests within the country. And this was all deployed within the first weeks after the tsunami. The core capabilities of Savannah software that was deployed back in 2004 were really the same at its core today, and it really provides a means to track organizations, who is responding, what services they are providing, and the geographic area of their coverage, as well as providing contact information and a means to contact them. Missing and found persons is also sort of a core capability, understanding where the people are, what their status is, whether they are missing, deceased, injured, at a shelter, and that all helps to serve family reunification efforts. Another core capability is dealing with requests, whether requests for help, requests for assistance or information, and being able to track that and provide a means of tracking that until the needs are met. And then finally, to have a location registry where you're able to sort of map and understand where all the important places are, such as shelters and hospitals, warehouses, and that's really a core capability of any disaster management system today. So today there are actually dozens of modules within Savannah software that's designed to serve a number of needs, I said, from biosurveillance to logistics management, missing persons tracking, and organization tracking. And so there's a lot of different capabilities that are in there. The technology is designed to run on a broad variety of platforms and mobile devices. It can be easily translated into other languages, including those using alternate character sets and right-to-left scripting. And our support for open data standards really facilitates the integration of multiple data sources and allows us to be an effective data provider as well. Particularly in the area of mobile devices, we're actively developing applications for use on devices such as Android phones and iPhones. Here as well, you can see the use of one laptop per child in the upper right, which is a very inexpensive device with built-in mesh network capabilities, low power requirements, and we're looking at these as a platform that could be deployed and very useful on the immediate aftermath of disaster. We've also done some experiments with very inexpensive netbook computers as sources of deployable platforms, and have found that a device costing only a couple $100 can probably support up to a dozen users. We're entering and dealing with mostly textual data when you're collecting this sort of information. For those in the U.S., we've been working on supporting more NIMS and ICS protocols, including building in support for organizing activities by emergency support function, by assigning ICS titles to different individuals in their roles, and using symbology that came out of a Department of Homeland Security working group for mapping within our mapping client. So we've been working on that. That'll be useful information for this audience. In terms of mapping, I've mentioned that's been a major focus over the last year. We've added support for the use of local servers from OpenStreetMaps and Google Earth, and have experimented with integrating UAV imagery and providing some streaming capabilities into Google Earth. We've also had some discussions with Esri, who've recently published some APIs that are allowing us to start providing support information for customers who use Esri as well. Historically, since the tsunami in Sri Lanka, Sahana software has been used by national and local authorities to assist in response to over a dozen large-scale sub-onset disasters. So our software is fairly tested in these environments, and our team is very experienced at providing support for them. But even more important, I really think, is getting solutions adopted in advance of disasters, because you really don't want to be introducing these systems after a disaster has started. So the best thing is to get them in place in advance. And so recently, governments of Taiwan and Sri Lanka have put things into place, and I'm going to show you a couple of slides about how Sahana has been used in the U.S. Again, first in the city of New York. I've lost the slide about the city of New York. It's right here, but in the city of New York, the Office of Emergency Management there has been using Sahana software since 2007 to manage its sheltering and mass care plan. And this plan scales to provide shelter to over 800,000 persons in over 500 shelters that are staffed and supported by over 60,000 city agency staff and volunteers. So this is a challenge and a system that can only be managed by a technological solution that's based on their response plan. And it provides, the system design provides real-time updates to their emergency operations center, such as providing color-coded tracking of shelters, so as they fill up, they show up as sort of colored pins on the map, so they know when to shut down and to open up new shelters. The next slide here is on the National Library of Medicine. It's another user of Sahana software. As part of the partnership with the Bethesda Hospital's Emergency Preparedness Partnership, they've developed a Lost Person Finder project based on Sahana software that ties in information that comes from the public for reporting missing persons with information of victims who are at local hospitals to be able to do some reconciliation. And they have some visualization tools as well as a web-based and iPhone application to allow people to access that system. Sahana software has been recognized by a number of awards, which is always nice, including Gartner. Last year, we were named the Blue Vendor in Risk Management and Compliance for our capabilities of helping organizations respond to disasters that impact them. There have also been a number of case studies written up on the effectiveness of open source software and Sahana in particular in responding to disasters. And they're listed here, and that list is available in the slides I think that IAM is making available and on our wiki. We work with a bunch of different groups from government and primarily technology companies, other open source projects, academia, and as well as volunteer communities such as Crisis Commons and the Crisis Mappers Network. So that's by way of a long introduction that brings us to Haiti, which is the focus of the rest of my remarks. As I said, Haiti was a massive earthquake, and that really had a number of challenges logistically because of the scale and where it was located, the numbers of people affected. And there was a massive response from our own community of volunteers, as well as those which I just mentioned, and a number of partners that we've worked with. So today I'm really going to focus on 5 sort of sub-case studies on the Haiti earthquake response. Starting with person and missing person finders efforts, and then going on to talk about how some crowdsourcing tools, pulling information from text messages sent by SMS on cell phones was utilized, as well as Twitter, information that was posted on Twitter. And then finally talk about how some advanced mapping capabilities were used to provide better information through relief workers in Haiti, both generally and particularly in the case of hospital management. So these all are really illustrative of the 4 takeaways that I've listed here that are sort of the main points that I want you to walk away with, which is about the coordination across different initiatives. So the activities that Sahana has been involved with has involved other groups, and we're very supportive because we each bring different capabilities. So we are in a mapping system, but we have a mapping client. So we rely on other people to develop good geographic data that we can make sense of. And we are also like to provide data to other people as well. And that's really in the spirit of humanitarian open source software. The other thing is that there is value in the use of non-traditional sources of information that come from crowdsourcing and social media, especially when it is structured. And that's really the lesson that came out of Haiti, is that there is a way to get this data structured in a short period of time to make it actionable by people who are trying to save lives. And that this type of effort can address critical information gaps that exist through volunteer efforts. So the first challenge and main area of the first sort of 2 case studies is helping the victims, identifying where they are, who they are, and who needs assistance. And this is one of, this is what really the response phase is about, is helping the victims of disasters. So, missing and found persons. This is an interesting story. So, really, it comes down to the heroic efforts almost of an individual. His name is Tim Schwartz, who is determined to help the international community avoid the mistakes of the past. For example, after Hurricane Katrina, there were at least 52 distinct missing persons websites that propped up on the internet. And these were places for people to report missing persons or persons who were found or known. And they were hosted by mostly well-meaning news organizations who wanted to do something about Hurricane Katrina. But the problem is that none of these systems talked to each other. There was no back-end system to integrate the data from one site to another. The format that the data was in was different from site to site, so it became very difficult to reconcile all of the information that was collected. And it actually took months and a lot of effort and money to actually do the reconciliation after Hurricane Katrina from this. So after the Haiti earthquake, the same thing started happening. And what Tim did is he started a site called HaitianEarthquake.com, and he focused his technology efforts on designing scrapers that would go out to all these different websites and pull all of the data from them and put it into a single place, his site. That basically served as an aggregator of all the different missing persons websites. So by doing this, he created the best site and then tried to get the others shut down so there wouldn't be competition and there wouldn't be duplication of effort. What was interesting about that is that what happened then is Google got involved because they wanted to help as well. And he basically handed over his efforts to what became Google Person Finder. And Google was able to use their influence as a very large technology company to help convince other organizations to basically shut down their own missing person site and instead to post a widget, which are shown on this screen, that people could embed on their site so people could go to the WashingtonPost.com and still report a missing person to the Google registry. And this was actually a great innovation because, as I said, it avoided duplication and allowed all the information to go into a single place. And eventually, all of these other sites were shut down except for Facebook and CNN's iReport, which served other purposes besides just collecting missing persons information. So another effort which came up which involved Sahana is the National Library of Medicine launched a version of their person finder, or their missing persons project called the Haiti Earthquake People Locator. And this is built on top of the Google registry, so it pulled data in from Google's site and allowed people to use their tools, including the notification wall here and the iPhone application, to provide updates to the missing persons registry. And the reason why this works good is because the missing persons, the person finder system was based on an open data standard called Person Finder Interchange Format. And that allowed multiple systems to have interoperability with each other for missing persons information. So a record collected by the Haiti Earthquake People Locator could be it would provide an update to the information in the master list that was maintained by Google Person Finder. And so the use of open data standards in this sense really added a lot of value and allowed people to add capabilities to a master repository. So the lessons that come out of this really is that first, that there is great value in having a single and official master repository for missing and found persons information. One thing that wasn't done in Haiti, and this was because I think of chaos that was created by the quake itself with the Haitian government and the responding agencies, is that it is very important to coordinate with government and the responsible authorities and the Red Cross and any other stakeholders who are legally responsible for caring for the victims of disasters and reuniting families. And this is something that's been discussed among the people who are working on Person Finder issues, including Google, and also talking to the Red Cross, who have the international mandate for family reunification efforts after disasters and conflicts. There are also important, I think, privacy concerns that come up depending on the country about posting information publicly to websites that need to be handled according to both national standards and international protocols. And this is something that the people working on missing persons systems are very aware of. As I mentioned, the open data standard really does allow people to provide added value to a system of collecting information in this. So I'm going to move on from missing persons to talk about both Project 4636 and Tweet to Tweet. I don't know if any of you know about these, so I'll give you some background on these projects. But they're both basically efforts that were designed to leverage a global volunteer community to make sense out of crowdsourced information that comes from SMS text messages, as I mentioned, as well as unstructured posts made to social media sites such as Twitter. And to get all that information into a structured format that can provide actionable information to first responding agencies. Project 4636, I'm going to leave this slide up for a little bit because it involved many different groups and it was a little bit of a complicated process, so I want to make sure that I explain this correctly. So the basic idea behind Project 4636 was to be able to collect information sent by citizens in Haiti who would send a text message to a single number, a short code, 4636, that would be looked at by someone. So requests for information, requests for assistance, requests for rescue, these are the type of things that happen. And so this required the work and coordination of people who were on the ground, which are shown here. You can see the laser pointer. from a nonprofit technology organization called Instead, who worked with the local cell phone providers, Consol and Digicel, to arrange that gateway through a text message from 4636. And they were working in country instead with the Thomson Reuters Foundation on what's called Emergency Information Service, which was a project was being put in place to do election monitoring in Haiti. So they had some systems already in place to be able to take in text messages and get them into a simple database so people could look at them. Another important piece of the puzzle was having a public information campaign, and that took place in Haiti to spread the word via megaphone, via radio, via social networks as well, to inform the population that they could send a message project to 4636 and someone would look at it. A huge part of this project was sort of in the middle here, which was organizing a group of volunteers who mostly came from Haitian Americans who belonged to the Service Employees International Union, who lived in the United States, literally thousands of them, who provided translation of the messages that were sent from Creole into English, and categorized them and got them entered, into, again, a database that other people were able to work with. They were also able to help identify the location of where things were being talked about, whether they said someone needs rescue here, and very often just from their local intelligence, because they were from Haiti, they might know where that was and were able to pinpoint it on a map. They would also get in touch with the people sending the messages directly by SMS to get more information if it looked like a life-saving situation, to get more details, and then would flag those important messages for attention by someone who would then communicate that back to people in the ground in Haiti, either through the Emergency Information Service, people who work with the Red Cross, or through UCHD, which we'll talk about in a minute, who was providing information and support to the U.S. Coast Guard and U.S. Southern Command search and rescue teams. So once the information was translated and categorized, it was fed into a system supported by UCHD, which allowed people to visualize this information and then also feed it back, as I said, to the search and rescue teams. Sahana software was also able to pull all this information in, and I'll show you an example of that in a minute. And missing persons reports were fed from this into Google Person Finder. So it was a project that involved quite a lot of different organizations and a very complicated flow of information between a bunch of different groups, but it was able to take large amounts of data that didn't make a lot of sense and be able to translate it into the language that the responders needed to see it in, get it categorized and prioritized, and fast-track for action if there was information about someone who needed rescue. And several victims were pulled out at the level in Port-au-Prince from messages that originated on this system. So it was, it was very successful in that regard. As I said, the volunteers who contributed to the translation were there was mostly located in the U.S., and there was a huge war room about it up in Boston that did this, but they were also located globally, wherever anyone had Haitians who knew Creole, all contributed from wherever they were, including places like South Africa and Sweden and Norway and China and Hawaii to contribute to this effort. Tweet to Tweet was a similar project that was supported by Project EPIC at the University of Colorado. And the idea behind that was to encourage Twitter users to use hashtags to create machine-readable syntax within a Twitter post. So, for example, all messages about the Haitian earthquake were supposed to be started with hashtag Haiti. And then information about the location of what someone was talking about, you put hashtag LOC, and what followed would be information about the location. Hashtag need would identify the need that you're reporting, and there were some other conventions. And what that allowed to do is it allowed machines basically to scan all of Twitter and identify requests for information, requests for assistance, and categorize them automatically and capture them into a database. And that allows it to be sorted, filtered, and mapped to a little bit lesser degree. So as I mentioned, all of this information was able to be pulled into Sahana, and we had a request management system. Admittedly, this system wasn't used by a lot of aid agencies, but it was a good proof of concept. And so we're able to take all of the information that came from 4636 and tweet to tweet and basically pull it into Sahana. So what that allowed was this, for example, shows all of the information that came from Project 4636 related to water shortages. And as you can see, that in the middle column under location, all of these posts have been geolocated, so you can see them specifically on the map where the request is, and it allows organizations to make pledges against it that can be tracked by priority or filtered in some other means. The next slide is about, shows the tweet-to-tweet posts. None of them, unfortunately, were geolocated, so there wasn't location information about them, so you would have to look a bit further. It wasn't as effective a means, but now that there's actually built-in location services within Twitter, the data that comes out of this project is actually a lot more useful, and we've seen that in places like the Pakistan floods. So the lessons that come out of these two projects are really that they are excellent examples of getting actionable information in a structured format from non-traditional sources. And they also highlighted the effective coordination between different groups, both traditional and non-traditional disaster response organizations, but each of whom brought distinct and different skills and capabilities for the humanitarian purpose of helping the victims of the earthquake in Haiti. The next challenge, and sort of the final area, was in the area of sort of mapping and locating information and understanding where shelters were located, where the organization providing assistance. And so in general, better mapping is a huge requirement that's been identified by all disaster response agencies. Being able to understand where things are is really at the core of organizing their activities. So OpenStreetMap. This is where a project like OpenStreetMap really had a huge impact. OpenStreetMap is a community-supported, publicly editable map of the world. It's like Wikipedia, but it's a map. It allows anyone to go in and add a road, a building, mark where something in, and there's a community of people who review all this and provide updates, and anyone can use this. So in Haiti, OpenStreetMaps would use the OpenStreetMaps community global volunteers used the high-resolution imagery, both satellite imagery, and there was also some flyover airplane imagery that was made available by the World Bank to very quickly provide updates of the map of Port-au-Prince in the affected area. And that effort continued with providing information of the temporary shelters, the hospitals, and other important places in the world. And that information can also be downloaded onto base maps and onto handheld GPS devices that were used by relief workers arriving in Haiti, so they would have a handheld version of where things were. And this is very important for a number of reasons. And I want to show you two slides that I'd like to show on the effect that OpenStreetMap mapping can have and why it's particularly effective for crisis mapping. So if you go to Google Maps and look at Jalalabad in Afghanistan, you get a picture that looks like this. And you can also add the satellite imagery layer, and that adds a lot more detail. You can see where the city is, and that there's a lot of information there. But that's just an image. It's not actually data. So even when you zoom in on the map and remove the satellite layer, you're left with a couple of roads and a dot on the map from Google. And that's basically all the information it has. Now, I don't want to pick on Google because I love Google. Google provides a lot of funding and support for our organization. So let me show you, this is the Yahoo Maps view of Jalalabad. It looks pretty much the same, as does the Bing Maps view of Jalalabad. Now, by contrast, the OpenStreetMaps view of Jalalabad has a lot more information and a lot better data. And the reason that it does is that the humanitarian relief organization workers who work in Jalalabad wanted to have a good map of where they were working, so they contributed to OpenStreetMaps and added a lot of the roads and information that you see in this slide. So moving back to Haiti. This is a Google Maps view of the area in Port-au-Prince near the airport that I captured in about May 2010. And it's much better than Jalalabad, obviously. There's a lot of roads, there's a lot of information behind this map. However, if you look at OpenStreetMaps captured on the same day, you see that there's actually a lot more information on this map. All of the little tents that you can see, like here, are temporary shelters that cropped up. These very small dots are the location of organization offices that data actually came from Sahana. There are a couple of hospitals that are located here and here on the map. There's a lot more information and a lot more data about where things are in Haiti that people who are working with the disaster response are concerned and interested in. The lessons from this is that again, this more accurate mapping leverage the global volunteer community to provide accurate and current data. That's one way of crowdsourcing support. Another thing is that the best information typically comes from OpenStreetMaps. The best map information after a large-scale disaster like this, even if the starting point isn't as advanced as some other sources, because of the community's interest in providing post-disaster map information. The other thing is that Esri, for example, and a lot of emergency management agencies work with Esri, and now supports using OSM data within their systems, so that's something else I wanted to point out. Sahana software also can import and export data to OpenStreetMaps. And finally, I want to stress that the data itself is critical, not just the imagery. And by knowing where a shelter is, for example, you can now start registering people at shelters. You can track logistics requirements at shelters. These are all things that our Sahana software does, and it's why we have such great support for OpenStreetMaps, because this is very mutually supporting. The last sort of case that I have is to talk about hospitals management. After about 10 days after the earthquake, there was official requests for information that were coming actually quite publicly from the U.S. government, the U.S. Embassy in Port-au-Prince, the medical planners at U.S. Southern Command, as well as the Pan American Health Organization. They needed to know for their own internal planning and coordination, where were the functioning hospitals located? How many beds did they have available? What services were they providing? There was no single resource for this type of information. It was very important for one hospital as well, who had too many patients, to be able to know where they could transfer patients to. And so there was a huge need and requirement around that. So this is an area where we sort of stepped in to assist. And we started with a list of 3 earthquake hospitals that came to us from the Pan American Health Organization and the Haitian Ministry of Health, which is MSPP. And to that, we added information that we pulled from UN sites such as Relief Lab, as well as OpenStreetMaps. And when we were done looking at that, we found that there were still 100 of those 157 hospitals we couldn't map. We did not know their coordinates, their latitude and longitude. Sometimes we even have the street address, but there is no system for geocoding places in Haiti. So we needed to figure out a way to find the latitude and longitude. So what we did actually was interesting was we crowdsourced the solution. We issued a public challenge to asking people to help us We published the names and whatever information we had, and we asked people to get back to us with the latitude and longitude, and that's all we wanted to know. And that only took 24 hours. Within 24 hours, we had coordinates on all but 3 of those 157 hospitals. And the solutions that people took were very creative. Some read news articles that described or mentioned a particular hospital and where it might be located at the end of a road, and they looked at a map and they tried to figure out where that could be, and so they put a point on the map. Others worked with other sources of data like OpenStreetMaps and were able to do some reconciliation and figure out that the hospital on our list was one that someone else knew where it was and had already bought it. There were people with local knowledge, having visited Port-au-Prince or having worked there themselves, who were able to look at the map and identify where it was. Other people actually picked up the phone and called someone, did email, or just made an educated guess. Some of the hospitals were located in small villages, so they just gave us a pinpoint of where the village was. A very important point that happened in the week after that challenge was finished was we had a mapping, a GIS expert who was an OpenStreetMap contributor, use the World Bank high-resolution imagery to basically geo-rectify the data set. And so they looked at where people were telling them hospitals were, and they were looking at high-resolution imagery of that location. And you could tell if it was a hospital or not, or if the building had collapsed. I mean, some of them were clearly, there was a pinpoint on top of what was a gas station. And so we knew that wasn't where the hospital was, but you could see in the imagery, because of its high quality, that the hospital was down the block 3, half a block down. And so we were able to basically improve the data, and that resulted in us having really the best data set of hospital data about 2 weeks after, 2 to 3 weeks after the earthquake. We put this in our hospital management system, and that was able to be mapped within Sahana, and updates were able to be made, and we had some users do that. But also great value was we provided this data as a feed in multiple formats, including KML, which is used by Google Earth, or something called EDXL-HAB, which is the Emergency Data Exchange Language, which is an XML standard for hospital availability tracking. It is a data standard that was written specifically to help manage and deal with this particular problem. So we had hundreds of organizations pull this data from Sahana, and it was a very successful effort. A number of groups as well built on this data set. There was a very important effort coordinated by the U.S. Department of Health and Human Services that also involved the Pan American Health Organization, PAHO, and a bunch of other groups to help create a master list of all hospitals and medical facilities in Haiti, an official master list. And so we started by contributing, sort of the beginning of that, and other groups built on that, including Google and some private sector companies as well, that all were pulling data from the master list and creating capabilities. Unfortunately, we were the only system that sort of had an open standard in EDXL-HAB, and there are some reasons for that. It wasn't quite a perfect fit with the needs of Haiti. It was a standard that was written for use in the U.S., and so there were some shortcomings with it, and we're working on those now with the group responsible to help improve that. So in the future, hopefully we'll have a data standard similar to PFIF, Person Finder for missing persons. We'll have a standard for hospital information. In the fall, we made some enhancements to our system because there were cases of cholera that came up in terms of tracking a facility's ability to handle cholera and their supply needs, in particular for antibiotics and IVs. And we also updated our mapping system to be able to display that information within our mapping client to be able to support the cholera issues that were going on. So I guess the final lessons from the hospital management side were, again, an important example of using sort of crowdsourcing or going out to global volunteers to address critical information gaps in a rapid and timely and accurate manner, ultimately. And again, to stress that we kind of promote and feel that an open data standard-based solution is going to allow for better sharing of information across diverse organizations. summary, I think I've talked a bit about the major takeaways and themes of the case studies, but in conclusion, I do want note that the impact of sort of the volunteer, open source, and technology community had in the Haiti response was admittedly limited because sometimes the information did not get to the full response community. It was a volunteer effort outside of some particular relationships we made with the search and rescue and relief operations through Project 4636 and the hospital system. People didn't know that these resources were available to them. In fact, I was told that by a UN staffer at a conference some months ago that she wished she'd known that these systems were out there because they could have used them in Haiti. So improving that in the future is definitely something. Sorry for the background call. In the future is definitely something that can be addressed through the deployment in advance of disasters and systems like this, but especially through partnerships and standby agreements with national governments. Hold on a sec. I'm just going to turn this off. Sorry. National governments, UN, international organizations having partnerships and standby agreements with them such that they understand what resources are there and what commitments and resources can be available. The last thing I just want to address is that there are several common misconceptions about open source, which open source does not mean open data or that the information is insecure. That information can be shared only with those who you authorize, and there are certainly professional standards applied to data security and data standard that have been done in the relationship. This is a common misconception, so I just wanted to mention that. So that really comes to the end of our slides. Just wanted to thank you for your attention. I think we have a few minutes for questions. I saw someone had a hand up. But otherwise, the information here I think will be available through IAM or on SlideShare as well, which is on this slide.
Great. Thank you very much, Mark. Were there some questions there that you can see?
I don't see any questions in the Q&A.
Okay. Thank you very much, Mark. We appreciate your presentation.
Great. Thank you.
We're going to be at break for maybe 8 minutes, and then we'll be on to our last presentation on Maurice Ramirez. We will come back to you at 4 o'clock.